Okay, so for the end exam, from electric field, magnetic field sections, and secondly from the Maxwell's laws. Thirdly, from uniform plane waves. Then transmission lines. Finally, from dipole antenna. Currently, we discussed about these sections, which were covered for the mid exam as well. However, all these sections will come for the end exam as well. So these sections we need to cover today. So if you have any questions regarding these sections, you can let me know. So in the last class, we discussed about the uniform plane waves, and we stopped at the properties of uniform plane waves, as I remember. So if I'm not correct, please, you can let me know. So we discussed about the properties of uniform plane waves, and the uniform plane waves were having properties such that it has a very uniform behavior along the direction of propagation, and it has uniform behavior throughout the propagation period. So it has a uniform amplitude, it has uniform frequency, and so on. So although we take this plane waves into consideration, in the real world, we have signals. We have signals that propagate with some under some environmental conditions. So signals propagate under different environmental conditions, and due to the conditions of the environment, the wave properties vary with the time, and the wave properties change. So basically the wave amplitude deteriorates. So in the real world, the signals propagate under different environmental conditions, and therefore the waves in the real world, the waves attenuate. Waves attenuate. So in the last class, we talked about uniform plane waves, and in that case, we assumed that the attenuation of the wave is 0. Attenuation means the reduction in the amplitude of the wave. Okay, so the reduction in the amplitude of the wave we discussed, we assumed was 0. We considered the attenuation 0 case. So in the real world, the waves attenuate. So therefore, we need to adjust uh, our calculations in such a way that the wave attenuation is considered also. So first we need to know what this attenuation is. So attenuation is the reduction in the amplitude and the energy of the wave. As it travels through a certain medium. So we need to consider the real world conditions, and we need to update our mathematical models of wave propagation based on that. Okay, so in the real world, the wave will the amplitude of the wave will attenuate. So it will decrease with the time. So the wave amplitude will start with a high amplitude. With the time, it will decrease uh, along the direction of the wave propagation. It will sometimes reach a value very close to zero. So this is the wave attenuation that will happen in the real world. So wave attenuation that we can observe in the real world scenarios. So we need to add this attenuation factor also into our calculations in order to find out up to what point the wave can propagate reliably, such that the receiver can receive some signals, uh, and the receiver can decode our information, or the receiver can receive some kind of a uh, power up to above a certain threshold. Okay, so the electromagnetic waves can propagate either in wireless medium or in wired medium. So in both cases, when we take into consideration the telecommunication applications, uh, where we use the telecommunication based infrastructure, telecommunication networks to uh, transmit signals from certain transmit signals from towers to devices in far distances. So we send signals, and the devices at the end of the or at the area of the coverage will receive some signals reliably from the base station. So we need to decide the coverage of the base station based on the attenuation of the wave that the wave is uh, I mean wave is undergoing once it is propagating through the environment. So we need to consider these wave propagation features to understand up to what point we can transmit the signals reliably through the environment to the end devices. So in telecommunication sector, we can see that, and also in power systems, when we are transmitting high frequent power signals, or high frequency energy signals through wired cables, we need to understand like when and how, when and at what location we will have some deterioration in the wave propagation, and that we will lose the power of the signal. And at that location, we need to amplify the amplitude of the signal, such that we are able to reproduce the original signal and transmit it over to a longer distances. In cases where we are distributing the power to households from power generation stations, then we need to use methods to distribute the power signal, the electricity power supplies over long distances, and we need to decide what is the wave propagation uh, features and the attenuation that occurs on the wave. So in order to understand the attenuation, we need to understand we need to understand what factors affect the attenuation. So there are some factors which affect the attenuation. So one factor is absorption. So absorption means the process of energy absorption. Energy absorption when when the wave encounters medium such as water, rocks, etc. So, for example, when we are considering telecommunication sector, when we are transmitting, wave signals from the base station towards the area, once it hits with some kind of a rock, mountain, let's say, uh, or some kind of a water body, the amplitude of the wave deteriorates, and it can have a lower amplitude after hitting the rock and the uh, such kind of like hard objects. Its amplitude, the amplitude can deteriorate. Also, in this scenario, the direction of the wave also can change after hitting these obstacles. So after hitting obstacles, the wave direction can also change from the initial direction. So that we call as scattering, the scattering effect, right? So first we discussed about absorption. So absorption means the energy absorption that occurs when a wave is hitting a certain obstacle in the direction of propagation. And next, once after it loses energy, another thing that happens is that the wave changes its direction of propagation after hitting these obstacles. Wave changes its direction and loses energy once it encounters obstacles. So once the wave is hitting a certain obstacle, let's say again the mountain, it hits here and it is getting spreaded over in different directions. So part of the wave can go in one direction, part of the wave can go in another direction. So in that case, like what happens is that the energy of the wave is getting dispersed in different directions. So the original signal's energy is getting reduced. So third thing is the reflection. Reflection is another phenomena that can cause the wave attenuation. So what happens in reflection is that wave encounters a certain obstacle, and part of the wave is going back to the same medium that it was traveling initially. So wave encounters a certain obstacle and move back to the same medium. So what happens here is that there's some wave that is moving in the free space, and then it hits some kind of a mountain or some kind of obstacle, and part of the wave uh, that is hitting in this obstacle will reflect back or will again move back into the same same medium or same direction that it was, I mean, incident on. I mean, this is the forward wave, and part of the wave which is hitting this obstacle will move back in this direction. It will go towards the same direction that it came from, and basically it will go in the same direction but with lower amplitude. So I will just draw it. It's so part of the wave will reflect back, and what happens is the amplitude of that reflected wave will be lesser than the incident wave. So incident wave is the wave which is hitting the obstacle. The reflected wave is the wave which is reflected back from the incident wave. Part of the incident wave is getting reflected back. So this reflected wave will have a lower amplitude than the incident wave. Uh, However, because of this reflection, some power of the initial signal will be lost. So when we are designing systems, we are targeting to reduce the reflection as much as possible. So we want to reduce the reflection as much as possible. So we mathematically model the amount of reflection using parameters such as reflection coefficient. So we'll learn about that when we are discussing about the transmission line. Right? So that is basically regarding the wave attenuation. Apart from that, in order for us to mathematically give a value for the attenuation, we denote the wave attenuation using a factor called as attenuation factor. So wave attenuation, we denote mathematically using a certain equation. So basically, I'm not going to go into details regarding the wave attenuation mathematical equation. So for the moment, you can keep in mind there is a certain factor that we denote as attenuation factor, which is used to denote the amount of wave attenuation that happens on the wave uh, in terms of its amplitude. So that is modeled or denoted using this attenuation factor parameter or alpha in general. So I will get into the transmission line section, and I will discuss more about this attenuation factor. And also, I mean, in general, the attenuation factor is related to the propagation constant. Okay, so these are actually mathematical equations. So I will anyway, I mean, I'm not going to go into detail on this equation. However, like there's this equation, this denotes the propagation of the which is used to denote the propagation of a certain wave inside a certain medium. Let's say let's say we are transmitting a certain wave or a wave of like let's say uh, we are transmitting some signal from uh, through a certain medium, and in that case the propagation can be denoted using the propagation constant, and it will include the attenuation factor, and it will include the phase constant factor, or this is the wave number. This is the wave number. So this denotes the uh, the rate of change of the phase, rate of change of phase, rate of change of phase, rate at which the phase of the wave is changing. So basically what it means is that the rate at which a certain point in the wave is changing. Right? So the wave number gives us the rate of change of phase. How much of in what frequency a certain point in the wave is changing. So that idea is given from the wave number. So based on the wave number and the attenuation factor, the propagation of the wave is determined, and that propagation constant is used to determine the propagation of the wave. So this propagation constant is used in certain equations related to the behavior of the wave inside a certain wave. We will talk about that, so don't worry about that section for the moment. So basically, when we are trying to model the wave like behavior, we are using an equation called wave equation. I think we discussed about wave equation for the electromagnetic waves. So after so going further, we can discuss about electromagnetic waves which are traveling inside transmission lines, especially, and how the propagation of the wave happens there. So when we are discussing about the transmission lines, we will talk about the propagation constant. So we will talk about the gamma when we are talking about the transmission lines, and the gamma is defined there. So basically, that's regarding the propagation constant and how the attenuation factor or attenuation constant is included in the propagation constant parameter. So by including this attenuation factor, we can define how the wave attenuation occurs when it's propagating through the space. So using the attenuation factor, we can decide like at what point the amplitude of the wave will deteriorate below a certain threshold, and based on that value we can decide, okay, we need to amplify the signal at that point, or else we need to set up more base stations near that area to get a more better coverage than before. So that is basically regarding wave attenuation. So we will move on towards the section regarding the transmission lines. So so far, if you have any questions, you can ask. Okay. So we will continue the lecture. So thank you for your comments. So actually, I just went through the section that I have covered for the regular students. So uh, in the regular students class, I have covered some sections related to transmission lines, and I will try to cover the same thing. However, I would like to, request you to go through that lecture also when preparing for the end exam. So the reason is that by the time I was doing that lecture, I was going through the content of the transmission lines uh, that I have done for the microwave class, and I have done some theories in that. Uh, so theories related to the related to some uh, content related transmission lines that I have covered for the microwave engineering class. So I need you to just study the regular students lecture. Uh, so the in order to make sure that uh, none of the content is lost uh, in between. So I will try to do the same lecture, but just in case, you need to refer both the lectures in order to make sure that you don't miss any kind of a content. So related to transmission lines, we are going to discuss about um, how we can how we can decide uh, the the reflection that can happen in a transmission line, and based on the reflection, I mean, based on uh, the the reflection happens because of wave attenuation in the transmission line, and because of the wave attenuation the reflection happens, and because of the reflection we lose some energy that we input to the transmission line. So when we are designing transmission lines, we want to design them such that the reflection that is occurring once the transmission line is connected to a certain load is minimum as possible. So in order for us to mathematically calculate the amount of reflection that happens, we need to use some parameters. So we are going to talk about those parameters that are used for measuring the reflection, and the parameters that are used to denote the amount of power loss. Apart from that, we are also going to discuss about the skin effect that can occur and the possible solutions to that. So under transmission lines, we are going to discuss basically those sections. So first and foremost, we need to decide the transmission, what are transmission lines, and we need to decide what are the basic places where we see the transmission lines. So let me share some presentation with you first. So okay, so when we talk about transmission lines, right, there are different types of transmission lines. So these figures basically are different to maybe the transmission lines that comes naturally into our minds when we talk about transmission lines. So we basically think about the coaxial cables that are used in power distributions and even fiber connections. So when we are talking about transmission lines, these circuits also, these miniature PCB circuits also have transmission lines. So